Hello and welcome. He's doing that thing where it doesn't tell me whether it's live or not, Nish, so I have to rely on you. Thank you very much. Apologies for that. Sometimes the streaming software that we use tells me that I'm live. Sometimes it does not. And today was one of the days it did not. So really, really pleased to have you back with us. And Nish, I think it's a haircut that I'm dying for more than anything as soon as lockdown is over. We're lucky to have Mr. Sam Winch with us again. Very good morning to you, Sam. How are you, buddy?
Good morning, guys. Yeah, very good. Thank you. Good. And it's Monday, right?
Yeah, Monday. Here we go again. Nish just told me this is week 5 of streaming school. Can you believe that?
Oh, fantastic. Well, it's gone so quick. But yeah, no, I can believe it. I've enjoyed every minute of it so far.
Yeah, it's been really, really positive. It's nice to know we're helping people. What do you think about people saying schools are going to be going back in 1st of June, or in some ways?
Yeah, okay. As long as it's done safely. At the moment I work with small classes, so it could be possible for my school, but it's quite a unique school that I work in. But I think schools of thousands, maybe if it was a year group at a time, maybe for a week at a time, I don't know, but it's not going to be as simple, I don't think, as all 5 years go back. Well, let's welcome back that 5,000 kids or 1,000 kids, whatever it is.
Yeah, I remember it was a school I once taught in London, and basically it was an old Victorian building. And I swear to you, if you had 2 adults side by side in the corridor, you wouldn't have. That was it. You wouldn't have gone down. So I just think about places like that. But hey, sometimes you want some responsibility, and I think in times like this, you're quite happy that I'm not a head teacher anymore, and I don't have to think about it as directly as I would have. So it's all theoretical for me. Do you know what I mean?
Yeah, absolutely. I've just come off a meeting actually about how we can make our lessons, tutoring like we're doing today, and using streaming school and other great things to get to our kids, but making it as interactive as possible. That's the main thing.
That's really, really interesting, because I think that's why a lot of people, even this, I class this as online delivery. This isn't online learning. This is delivery, and I think a lot of people are doing the delivery model, and the one to come will be whoever cracks online learning, the way that we follow it up. So some of our tools and products do that, but they're still now, you realizing more and more, like, I'm a huge Google fan, but using Google Classroom every day, you just realize its limitations. If, as a long-term tool, you can really see its limitations. So it's kind of like, well, what? There's still a gap for something. Have you seen Class In, Sam?
Yeah, I've seen a little YouTube clip of it. I think it looks exciting. Technology, though, for me isn't my strong point, but is it easy to use?
Yeah. Class In is superb. I've been really, really impressed with it. If I was to start streaming school again now, I would have got everyone onto stream. But we're all in our routine now, and there's probably, hopefully, only a couple more weeks where we're doing our assistance this way. But Class In is a fantastic tool.
Sure. Okay. Good stuff.
All right, buddy. Well, so you just let us know when you want us to switch over.
Brilliant. Okay. Well, welcome, guys. Welcome to another week of week 5, as we've just said, of GCSE mathematics, where today we're going to be working through bearings, a little recap of angles as well. But we will start off with recapping our 3 polygons and surface area. So, Nish, if you could share my screen, please.
Right.
As you can see on my screen, we've got the recap of 3D polygons. So we spoke about a prism, and we're talking about surface area again, remember today. So I'll just quickly recap the formulas for you. And we're going to do a couple that we didn't manage to get through on Friday, which is spheres, hemispheres, and pyramids. So prism, we've got 2 times the base plus perimeter times height. Cylinder, you've got 2 pi r squared, add 2 pi radius height. The cone, pi radius squared plus pi radius slanted side. Sometimes you're given the vertical height, sometimes you're given the slanted side. If you're given the vertical height, it probably is asking you for the volume as opposed to the surface area. And the pyramid, which is what we're going to come to today, so I'll leave that one for now, as is the sphere, although just recognise here the formula for both the sphere and the hemisphere in terms of surface area is actually quite straightforward. So we'll go through that shortly. Cube, also 6 faces, so it's 6s squared. And cuboid, there are 3 different faces, if you like, if you will. So find out the length and the width, find out the length and the height, and find out the width and the height, and add them all together and multiply them by 2. Okay, so today's lesson is based on 3D surface areas, just to recap those spheres, hemispheres, and pyramid. Then we're going to be looking at bearings, scales, and perhaps a quick recap of angles. Now, remember, scales is as simple as, if point A is 3 kilometers away from point B, you've got to work out the difference. If they'll give you it in centimeters, perhaps, or millimeters, and then you've got to convert it into miles or kilometers. So scales is it's just about conversion. Okay, so before we go into bearings, we're going to look at a couple of examples that we didn't manage to finish on Friday. So sphere was the first one. Here you've got the radius, which is 17. Now remember, the formula for sphere is 4 times the pi r squared. So we know, and I'm just going to load up my trusty calculator as well at the same time. We know that pi r squared, well, the radius is 17. So if I just load up my calculator and we do 17 would be the first job, 17 times 17, or 17 squared. Of course, that would give us 289. Multiply that by pi, which would use 3, that's not 3, that's 2. 3,629.84 yards squared. Okay, so that would be the answer to the sphere. Nice and straightforward, as we've said already. You just multiply pi r squared by 4. That will now move us on to the hemisphere before moving on to the pyramid. Again, remember the formula for a sphere is 3 times pi r squared. And here you've got the radius, which is 6 times 6, which is 36. And if we multiply 36 by 3.14, which would give us 113.04, and then multiply that by 3, which gives us 339.12 feet squared. Okay, so remember, formula is 3 times pi r squared. For a sphere, it's 4 times pi r squared. And just remember, we are working on surface area and not volume. Okay, remember, volume is slightly different in that you find 2/3 of pi r squared. Okay, right, pyramid. Final one on 3 polygons. The formula for a pyramid is base squared plus 2 times the base and the slanted side. Okay, so the first thing we're going to do is find out the base. Well, we know because this one is a square base pyramid, or at least we assume it's a square base pyramid because we've only got one side. So therefore, that must be 4. Of course, just the area of a square is base times height, or base squared. So 4 squared, which gives us 16. Now we're going to find out the base times the slanted height. So if the base is 16 and the slanted height is 10, well, 16 times 10 is 160. Okay, and 2 times the base times slanted height is 320. Okay, and we've got to add to that is the 16, and we get ourselves the surface area, which is 336 yards squared. Okay, so that's the recap of surface area. We looked at spheres, hemispheres, and pyramids. So just make sure you read the question thoroughly. The difference between, of course, surface area, volume, and anything else they might ask for. So we're going to move on to bearings today. 3 points to bearings. Nice and simple, nice and straightforward. However, we can work from a foundation onto a higher paper, because not only will they ask for the bearings, but they might ask you to accurately draw a graph as to where the bearing is moved from point A to point B, etc. Okay, so we're going to start off with the first point, which stipulates that bearings are measures of direction taken from north. So 0, 0, 0 degrees. Bearing always starts from north. So regardless of where your new point has moved to, if you're going to use your protractor, always start from 0 degrees. Okay, bearings are always measured in clockwise direction. So there are a few tricks and ways in which you can quickly work out if it's, I don't know, 340 degrees, or you can work anti-clockwise and work out it's 20 degrees and just minus that from 360 to give you 340. But in terms of how you're writing your answer down, it always must be written in a clockwise direction. And bearings are always written in 3 figures, and that's one that I would recommend just be mindful of that. They often try and trick you out with 3 figures as opposed to just 2 figures. So if it's 45 degrees, how do we write down 45 degrees? It's 0, 4, 5. Okay, now move on to a worksheet of some bearings. Just move that slightly. Okay, so we're going to use our trusty protractor today. We're going to use our trusty protractor. And here's just as many protractors. You could even use a semi protractor as well. But here we're going to go with ours. And as you can see here, you've got the little cross which goes on the A, and you've got the arrow that points to 0 degrees. So that's north. So we know that that's north. And you can use this as well if it helps to move around in terms of where we're going. All right, and I'm going to point this now to the answer, which I believe is 77 degrees. So how do we write that down? B from A is 0, 77. Remember, it always has to be 3-figure answers. And of course, we're working clockwise. Okay, move on to 2. Again, we've got to make sure, you see there, I've got 180 north, so we must change it to 0 pointing north. And we're going to use our little dial here to move, and that one there is pointing at 37. So again, it'll be 0, 3, 7. And if we go for a couple more examples, let's have a look at one down here, number 4. We point north to 0, and down here to 1, 5, 6. Now, what we're going to do in a short while is move on to some GCSE style questions, because what they're likely to do is not only incorporate a bearings question, but maybe a scales question as well, or even angles and conversion of measurements. Okay, now here's one that's beyond 180. So a couple of ways I could do it. I could just go, first of all, find my 0 and go all the way around, and obviously look on the outer side, which works clockwise, and the blue inner side works anti-clockwise. So if I go all the way around, I've got my answer, which is 2, 2, 4. Of course, try not to get into a habit of going anti-clockwise in case you end up writing 136. If I was to do 136, of course, it would just be 360 subtract 136, which would give you the answer 224. Okay, and final one. It looks very much like it's 270. Got to make sure your 0 is pointing forwards, up to north, and we go all the way around and we look on the outside. It's just short of 270. In fact, it's 268. So the answer there is 268. Okay, so we're well aware of how to measure our bearings. If we go back to the worksheet, just a recap of, on the left-hand side, you can see the use of the ruler as well, because it's likely that they're going to combine bearings with other types of measurements. So it might be distance, it might be that you've got to convert centimetres, as I said earlier, into kilometres, and then there might even be a third point. I think there's a question later on that we're going to work on based from a port, and you've got to describe how far away the port is, and we'll go on to that shortly. On the right-hand side, just be aware, you've obviously got north, which is 0 degrees, east 90 degrees, south 180, and west 270. And all these numbers are 3 digits, 3 figures, and all of them are working clockwise. Then, of course, you've got northeast in between east and north, southeast in between east and south, southwest and northwest. And then if we were going into more detail, you've got north, northeast, east, northeast, etc., etc. We'll go through them again in a short while. Be aware of course, your 90 degrees, 180, 270. And of course, they're 90 degrees within. So if you were to look halfway and you say southwest, well, half of 90 is 45. So if I just subtracted 45 from 270, or if I added 45 from 180, okay, there's a good chance that you might be posed with a question based on southwest, rather than just south or west. Okay, so I'm going to just give you some drawing and examples of questions 1 to 4. So slightly different tasks now. We're looking at moving or drawing a bearing as well as a distance. So I'm going to use both my ruler and my protractor. Now, if I can just share my visualizer, I'm going to move it down here so we can see the question 1. So I've got question 1. And we've got B is a bearing of 45 degrees from A and a distance of 45 centimetres. So first of all, if I was to just draw question 1, and we had the letter A, and a little point there. And the first thing I want to do is work out where's 45 degrees from A, which is, of course, there. And we're going to work along that line to find the distance. Okay, so the distance is 4 centimetres, which of course is, I can work backwards, and we go all the way. I'll tell you what, let me just move that down slightly, sorry. And we go 4 centimetres from point A. Okay, and we're going to go towards that line. 4 centimetres, if I start at 6, of course, I'm going to go to 2. Okay. And then this will be my point B. Okay, and this is what I'm going to label point B. So again, in your GCSEs, they might give you more than one aspect of the question. They might then ask you to move point B to point C, and then even ask you the bearing in which point A is from point C, or vice versa. But we'll go into those GCSE questions shortly. Let's have a look at question 2. Terrible one, 2. B is a bearing of 315 degrees from A and a distance of 5 centimetres. So again, if we can get our little point of A here, and just move that down slightly. So 0 degrees, of course, points north, and we go 315 is that bearing, and that's there. And we're going to work to 5 centimetres. So 5 centimetres from there in that direction. Perfect. That's absolutely spot on. And of course, we would then label this point as B. Okay. We're going to have a look at. We're going to move on now. We're going to have a look at the next part. This is a GCSE style question then. So it says the pilot of an aircraft wants to fly from A to D. And as you can see here, you've got A to B is a 90-degree right angle triangle, and B to D, which again becomes a right angle here, so we know it's 90 degrees, but the whole thing is a triangle. So first of all, it says the distance B to C is 1 mile. So if the distance from B to C is 1 mile, we want to know the distance between D and E, or E and D. Okay? And the way to work this out is the full distance of the base of the triangle is 210 miles. So therefore, if it's 210, what is a ratio, or even as a fraction, you've got 210 over 60. So if I can just share my screen with you now, I'm just going to move my visualizer over here. Brilliant. So you can see my working out now. So we've got A to D as a fraction is, of course, 210 over 60. And if I was to do 210 divided by 60, my calculator, where are we? Of course, I would get 3.5. I can do that for you now. 210 divided by 60 to give me 3.5. Okay, so the distance from E to D is 3.5 times the distance of C to B. So if you look at C to B, that equals 1 mile. So therefore, E to D must equals that 1 mile times 3.5, which of course gives us 3.5 miles. And then following on from that question, this was question A, which is worth, you can see at the bottom of the screen, is worth 2 marks. The following on question, I think it's letter B, is just for 1 mark, and it's multiple choice. It says, tick a box. How should the aircraft have turned at C to fly directly towards B? So if we look back, we've got the options 1 degree clockwise, between 1 and 2 clockwise, 2 degrees clockwise, and more than 2 degrees clockwise. If we look back here now, so we've set off 1 degrees off course, if you will. And when you get to C, if you were to turn exactly 1 degree from C back on course, you would end up working parallel with line B and D. So therefore, we would only reach halfway between E and D. Of course, that is 2.5 times the distance from A. I'm talking B and D. So therefore, if you were to do 2 degrees clockwise, you would end up, if you can follow my red toggle, falling below D. So actually, if we go back to the answer, the multiple choice answers we've got, the answer wouldn't be the first one. It certainly wouldn't be the fourth one or the third one, and it would be between 1 and 2 degrees clockwise. If we were being completely accurate, if we times 1 by 1.5, then you'd get your answer. So it's between 1 and 2 degrees would be the answer for that. And I'm just aware of time. So, Nish, if you could share my screen, please.
All right, cool.
So we didn't quite get to the GCSE style questions that I wanted to get to, but we will continue with that on Wednesday. So today we worked on bearings, and we touched on surface area at the start of the session. But be reminded that bearings can go from a GCSE style level 3 right up to a GCSE level 7. So make sure you know how to work your equipment. And I hope you enjoyed today's tutorial. And I'll see you on Tuesday for some PE and Wednesday for some maths.
Thank you so much, Sam, buddy. Really, really appreciate it. Enjoy the rest of your day.
Yeah, cheers, guys. You too. Have a good one.